In this video, we're going to focus on finding the domain and range of this logarithmic function. Now, what I always advise my students is think of the most simple type of logarithmic function that's involved with this. So that's ln x for this question. And you want to think of how that graph gets transformed to become this graph here. So let's think of the graph of ln x. Now, before we do, it is useful to know that the graph of e to the x, which crosses the y-axis at 1, when you reflect that in the line y equals x, that's when you get the ln function, in case you guys forget. The ln function itself, just ln of x, it will never touch the y-axis, and it will never, therefore, touch the negative part of the y-axis as well. Now that crosses the x-axis at 1 as well, so that's the graph of ln of x. From here, you are able to determine the domain and range of just the ln of x function, and it's going to help later on. So the domain, like I mentioned, the x values, they're never equal to 0 or they're never less than 0. So it's always where x is greater than 0. Now the range is the set of all the y values that come out of a function. Sorry, I forgot to mention that. The domain is all the x values that you can put into a function, and the range is all the y values that you can get out of a function. It makes sense that x can't be 0 or negative because we know the inside of a logarithm can't be 0 or negative. Now the range, it gets more and more negative the closer you get to 0, and it just keeps increasing. I've sort of drawn it as if it plateaus, but it doesn't. It just keeps increasing to infinity. So we say y is in the set of real numbers. Let's now apply a transformation to make this match the actual domain and range that we're trying to get. So first of all, x is being replaced with x minus 4. So that happens when g of x minus 4 is being applied. That's what gets you to ln of x minus 4. Now, what does this transformation do? It moves all the x coordinates 4 units to the right. That means that now our graph, instead of having an asymptote at y equals 0, it's now going to have the asymptote 4 units afterwards. So essentially, sorry, not y equals 0, x equals 0. It's now going to have it at x equals 4. So the graph is just going to repeat itself in terms of shape, but it's going to be moved 4 units to the right. And instead of crossing out 1, it's going to be crossing out 5 now, because 1 plus 4 is 5. And now what we can say is that the domain, the set of x values that you can point to the function, is where x is bigger than 4. But the set of y values that you point to the function, the range, that's unaffected. So we can just leave it there. Lastly, we need to apply one more transformation to make it exactly match the expression that we have. And in our case, that's just multiplying the left-hand side by 5. Now, when you do that, all that does is it just makes this value here appear here, this value here appear here. So it makes all the y values multiplied by 5. This value just stays as it is because y is 0 at that point. But that doesn't affect the domain or range at all. Y can still be any set of real values, and x still has to be greater than 4. And that's why this is the final expression for your answer. The domain is where x is bigger than 4, and the range is where y can be in the set of real numbers. It can be literally anything. Be sure to leave a like if this video helped and subscribe. I'd appreciate it a lot. Thanks for watching the video, guys. Hope it helped. If you have any A-level maths or physics tutoring inquiries, be sure to send me a message at www.excellineducation.co.uk.